Here's problem 1. We're trying to figure out what x's value is in this triangle. I have one side 21, one 24, and an angle right up between them. So sort of have a side, an angle, and then a side. If you remember in geometry, we called it side, angle, side when we're trying to prove triangles congruent. But here, when I have sort of a side, an angle, and then a side, I know, hey, I'm going to use the law of cosines to figure this out. Now, the law of cosine says that this angle across, or excuse me, the side across from it, the way it's written is, it's sort of the way I remember it is sort of like the Pythagorean theorem that says a squared plus b squared equals c squared. Well, this piece, which they call the c piece, this squared is the a squared plus b squared, sort of like the Pythagorean theorem, but the difference is we don't have a 90-degree angle there. So we have to take away a little bit. So we take away is simply take away 2 times the a side times the b side times the cosine of the angle that's between the two sides. That's why it's called the law of cosines right there. So this is the formula we're going to use. Basically, this side across from my 61, this is my c side, and then it doesn't matter which two, the a and b if you want to call them, are right there. The two sides that are on the opposite way, on the other sides from the angle right there. So I have c squared, which is what I'm trying to figure out. I'm going to just label it x, since that's who we labeled in the problem. X squared is equal to a, which we said was 21 squared, plus b, 24 squared, minus 2 times the a piece length, times the b, times the cosine of the angle. Well, that's the cosine of 61 degrees. Now what's nice is you can enter all this on your calculator. 21 squared plus 24 squared minus 2 times 21 times 24 times cosine of 61. Make sure your calculator's in degree mode though. When we do this, when I did it a little bit earlier, I got that it comes out to be approximately like 528.311 blah blah blah, something like that. Now to get x by itself, to get this length by itself, because it says that length squared gives me that. So just like in Pythagorean theorem where you got to end up taking the square root of both sides here, you're going to get approximately, it comes out 22.985 blah blah. So basically we're just going to say, hey, that's about 23 centimeters or whatever units of length we're dealing with here. Again, always with this law of cosines, I remember it by thinking of the Pythagorean theorem, a squared plus b squared, but then I got to take away a little bit, which is simply 2 times that length times the cosine of theta. There you have it, law of cosines problem for you.